So there are many problems that can be related to rational relationships. Anything that's a rate often can be related to that. So for example, velocity is a rate of or a ratio of distance to time. And so many of you guys have seen this and that you can put this in this kind of triangle here. So we can say that distance is equal to velocity times time. Time is equal to distance divided by velocity. Velocity is equal to distance divided by time. Okay, so that's something very useful that many of you guys seen in science. There's another rational relationship that is called the ideal gas law, or the pressure times the pressure times the volume is equal to the number of moles times R, which is a constant, times the temperature. Okay, or we can say that the pressure is equal to the number of moles, how many molecules there are. There's a constant times the temperature divided by the volume, which really means that if you increase the temperature, you increase the pressure, or you decrease the volume, you increase the pressure as well. So here's a problem here. We have a rational expression. So we have the pressure, we need a new expression for pressure when we increase the volume by 7 liters and decrease the temperature by 8 degrees. So here's my initial pressure formula. N times R times T divided by V. There's my rational expression. So we're going to increase the volume by 7 liters. Okay, so the volume is going to be increased by 7 liters. And my temperature is decreased by 8 degrees. Okay, so then we just rewrite that expression. So this is my P nu. So it's going to be the same number of molecules times the same rate, or the constant there, and the temperature is going to be the original temperature minus 8 degrees. The volume then becomes the original volume plus 7 liters. Okay, so there's my new rational expression. Okay, so just to highlight that, there's my new volume. There's my new volume, and here's my new temperature. So this is my new expression. So we can do this with velocity as well, but we can generalize with our changes can be generalized variables. So here we want a new expression for velocity when the distance is increased by x and time is decreased by a. So let's again first start off with our velocity, our original velocity, and we'll call it vi, which maybe call that pi. Okay, velocity is equal to the original distance divided by the original time. My new velocity is going to be when I increase by the distance by x and I decrease my time by a. Okay, so if I go faster in a shorter time, my velocity is going to end up being greater. So I'm going to have a greater velocity here. So when I rewrite this expression, my distance is going to be increased by some amount x. Okay, and we're increasing, so we're just adding on. So this has to be now considered a factor. The d no longer is a multiplying factor. So the d plus x represent our new factor. And our time, t used to be a factor here, but now we have to consider t minus a as the factor piece here. Okay, and I'll just again color code this. There's my new time, and this is my new distance. So I've gone further in a shorter amount of time, so my new velocity will tend to be a bigger velocity. Okay, so these are just working with variable expressions and how we can add on, and we just keeping track of these binomial parts as we generate these new expressions. And we have to be very careful once we generate these new binomial expressions. We have to treat these pieces as factors if we're going to do any work with rational expressions.